My name is Carlos Banks, this is Diego Quintero, this is Patrick Alvarez, and this is the modeling and control of robots, projects 1 and 2, analysis of the 4-bar mechanism and the synthesis of a slider crank. The first part of this project was to analyze and do the analysis and the animation of the 4-bar mechanism. This right here is a typical 4-bar mechanism. It has 4 links and 4 angles. For this specific project, our input variables were R1, R2, R3, R4, and theta 1. And we had to calculate theta 3 and theta 4. Our input variable was theta 2, which rotated 360 degrees. Using Gershon's rule, we determined that it was a type 1 mechanism and it was a crank rocker type. The second portion of the project was to determine the position analysis of a coupler link attached to the end of link 2. The inputs of this link were QS was 10 centimeters long, and the angle at which it was placed at was 35 degrees. The input angular velocity was 10 radians per second, and the input angular acceleration was 0 radians per second. The graph right here is a graph from our Excel sheet where we calculated the position analysis. As you can see, QS actually rotates a little bit farther than the end of R2. This is an example. This is our rendition in SolidWorks, and this is a real-world example of 4-bar mechanism. A real-world example would be an oil well, such as that. The end of R2 and R3 would actually be the head part, which rotates up and down to collect the oil. This is the last part of Project 1. We had to calculate the angular velocity and the angular acceleration of bars 2 and 3. Links 3 and 4. As you can see, link 3 was actually rotating faster than link 4. This could be the case because it was actually connected directly to link 2, which is the input variable. And now Patrick will talk about the synthesis of a slider crank.
Now, these were our initial values. When using our initial values, when we tried calculating the pole position 2, 3, there was no values. We were dividing by a determinant of 0, and that was mainly because values for A2Y and A3Y were the same, and values for B2Y and B3Y were the same. So when we graphed the coupler link positions, we can see that the coupler link is moving from position 1 to 2 and 3. So it's not really a flow that we would like. So in order to correct this, our first plan of action was to make all the link lengths the same length, make them all 35 inches, and change them a little bit from the original, and then readjust the angles by keeping some of the A positions the same and changing the B. We altered the angles and allowed for the coupler link to move in a better flow. Now Diego will continue.
Okay, so for this part, we graphed the point of C. Point C is actually this point where the bar will slide on this line. And as you can see here, C1, C2, and C3 forms a straight line. And in order to see if this line was correct, if the whole movement was correct, we needed to calculate beta 2. And if beta 2 was between 0 and 1, that means that the movement of the slider crank will be from C1 to C2 and from C2 to C3, which means it's doing the correct path. Here, now, we plotted having all of these constants will be, the values are R2, R3, and R4 will be constant. It will be plotting out, it will be getting as an output theta 3 and R1. Also, we plotted the joint B position in the coupler link, which is actually this point. And as you can see in our Excel, the graph, it has like an ellipse shape. And when we render our mechanism in SolidWorks, we actually have the same path rendered in SolidWorks. That means that exactly our mechanism was synthesized correctly. If you go to the next slide, you can see here that R2 is doing a complete rotation of 360 degrees, and C is moving from the point C1 to C2, and from C2 to C3. And the point B is actually performing the lift shape path that we were talking about before. A real life application for this type of system, slider crank, will be a piston sliding through a cylinder. And as you can see here, the crankshaft will actually be our R2, and the piston will be our sliding box. So as you can see here, the movement of this motor or of this link, it relates to this movement, and the piston will move in a straight line, just as our box is moving on this line. If you have any questions, please leave your comments above. Thank you.